we are just continuing from where we stopped in the previous video. Now, for you who has just joined us in this video and you have not watched the most previous one, you're going to be lost. You're going to be lost. But for those who have just come with me, we are just continuing from there. Now we are saying, I have got my replication fork which has been formed there, and we have seen here this was a 3', 5' strand, and I'm having the 5'. I'm having the 5'. I am having the 5' here. I'm having the 5', 3' strand here. And in the most previous video, we have seen that this one, we have called that one the leading strand, and then we have called this one what? We have called this one the lagging strand. Now, what happens on the leading strand? Remember, in the most recent video, we said that because these strands are oriented differently, they are therefore replicated differently. That's the statement we ended with in just the previous video. Now, what happens on the what? On the leading strand. What happens? We are going to begin with the leading strand. Why? Because we are already saying it's the leading, so it's what you're going to begin with. Now, on the leading strand, what happens? On this leading strand, what happens is this, that an RNA molecule, this RNA molecule, we are calling it a primer. An RNA molecule called what? Called a primer. Whose synthesis, whose manufacture, whose synthesis is catalyzed. Whose synthesis is catalyzed by an enzyme called primase, called RNA primase. RNA primase is the enzyme. We are saying RNA primase is the enzyme which speeds up the process by which this primer is formed. Now, this primer comes and attaches itself. It comes and attaches itself at the extreme end, where at the 3' end of the leading strand, and when it attaches itself there, this, we are saying RNA molecule called the primer, whose synthesis is catalyzed by what we call RNA primase, attaches itself where? Attaches itself on the 3' end, of the leading what? Of the leading strand. And we are saying this primer acts as what? It acts as an initiator. Initiating what? Initiating the process of DNA replication, especially on the leading strand. What do we mean? This primer comes, if that's my, assume this is my primer. If this is my RNA primer, whose manufacture has been catalyzed by RNA primase. Now it comes at itself here. And after adding itself here, this one acts as an initiator for other nucleotides. Remember, this is happening in the nucleus. So other nucleotides within the nucleus come and they attach themselves onto these bases. Remember, these bases, assume this is maybe like guanine, cytosine, thymine, adenine, like that. So the nucleotides will come and attach themselves here. Remember the nucleotides we have said, we have the pentose sugar, we have got the pentoid sugar with the phosphoric acid, and then with the nitrogenous base. Then allow a pentoid sugar with the phosphoric acid with the nitrogenous base here. Then we shall have another nucleic acid. Shall have another nucleotide. Nucleotide here, pentoid sugar, then phosphoric acid, then a nitrogenous base, and so on and so forth. Likewise here, we shall have a pentoid sugar, we shall have a phosphoric acid group, and then we shall have a nitrogenous base. But let me try to be more accurate. We have a pentoid sugar, we have phosphoric acid, we have a nitrogenous base there. So what happens after this primer has attached this primer? I've told it's an RNA molecule. RNA is also a nucleic acid which has also got bases. So it will also be having a base. We shall also have a base which will be complemented to this base which is here, which is on the primer. So this primer also has got a base which will be complemented to this one here. So when the primer attaches itself onto the 3' end of the leading strand, it acts as an initiator. And after initiating, then we are saying another enzyme, a second enzyme which I told you in the previous video, was another enzyme which is called what? Do you know it? Yeah, if you know, please say it. That enzyme is DNA what? DNA polymerase. A DNA polymerase. So another enzyme called DNA polymerase. After this primer has attached itself there, the DNA polymerase keeps moving along this leading strand, and it moves on this leading strand, of course, following what? Following the DNA helicase enzyme. So the DNA polymerase moves along the leading strand, and as it moves along the leading strand, it comes along catalyzing the combination of the DNA of these nucleotides, onto the leading strand. So as the DNA polymerase keeps moving along, this DNA strand, it goes on catalyzing the combination of these nucleotides with the leading strand, nucleotides of the leading strand. So as it moves, these nucleotides, which are free in cytoplasm, but that are complemented, those ones on the leading strand, they keep on joining together. So the nucleotide after the primer has attached itself on the 3' end of the leading strand, what happens is that other nucleotides, which are other DNA nucleotides, attach themselves on the leading strand, following what we call complementary base pairing rule. Meaning that if this is guanine, this nucleotide which should add itself here should be a nucleotide which has got cytosine as the nitrogenous base. If this is cytosine, the nucleotide which should then join itself here must be that nucleotide which has got guanine as nitrogenous base. This will be adenine, this will be thymine, like that. So these nucleotides also come and keep on attaching themselves onto the leading strand, but we are saying as they attach themselves to the leading strand, they follow what we call complementary base pairing rule. And that combination of these free nucleotides, these free DNA nucleotides within a nucleus onto the leading strand is catalyzed. That combination is catalyzed by an enzyme which we are calling DNA polymerase. But you can ask yourself, now, if this strand, if this one here was running in a what? If this enzyme, if this structure was running in a 3', 5' direction, what should this one show? In which direction should these ones be running? This one should actually be running. This one which should be added here should be running in a 5', 3' 3' direction. And I think from the way I've drawn my things, I need to rub them. The way I've drawn, because these ones I've drawn, when you look at them, if I'm to join them, if I'm doing them like this, you will see that this will be also 3, this will be a 3, this will be a 5'. So it means what I have drawn there is supposed to be the opposite. So it means if this is the 3', then whatever is supposed to be added here, these nucleotides which are supposed to be added here, they're supposed to be added in a 5', 3' direction. So it means if I'm to put the right thing, I'm supposed to put something which is like this. I have a pentoid sugar, I have a nitrogenous base here, and then I have a phosphoric acid group here. I have a pentoid sugar, I have a nitrogenous base here, and then I have a phosphoric acid group. I have a pentoid sugar like that. I have a phosphoric acid group here, and then I have a nitrogenous base here. I have a pentoid sugar like that. I have a phosphoric acid group. I have a nitrogenous base there. So it means, like I told you, if this is guanine, this must be cytosine, this must be guanine. The complementary base pairing group, this must be adenine. Complementary base pairing group, this must be thymine. And of course, here we should have 3 hydrogen bonds, 3 hydrogen bonds, 2 hydrogen bonds, 2 hydrogen bonds, if we have to follow complementary base pairing rule. So we are saying when this RNA primer attaches itself on the 3' end, 3 DNA nucleotides which are for DNA, it means nucleotides which have got the bases adenine, guanine, cytosine, and thymine only. Those bases come and attach themselves. They come and attach themselves onto the bases of the leading strand, following the complementary base pairing rule. And we are saying the combination of these DNA nucleotides which are within the nucleoplasm, the attachment of these free nucleotides onto the leading strand is catalyzed by an enzyme which we are calling the DNA polymerase, which enzyme keeps moving along the DNA strand, but moving in a direction following DNA helicase. And as the DNA polymerase moves along the leading strand, the nucleotide, the new chain which is being added in a direction which is a 5', 3' direction. It means even when this one has finished unzipping everything up to the extreme end, we shall have at this one here, we shall have a 3' somewhere there, so that we can maintain the antiparallelness. I hope you are following me, dear friend. Now, it means the rule is this. Okay, let me first finish what I'm writing here. So we have said, after this one, after the primer has finished initiating, then we have said the DNA polymerase moves what? Moves along. For those ones who like writing, moves along what? Moves along the leading what? The leading strand. Doing what? As it moves along the leading strand, adding what? Adding complementary nucleotides. Complementary DNA. Adding complementary DNA nucleotides. Adding complementary DNA, you can say adding DNA nucleotides onto the leading strand. Following what? Following the complementary base pairing rule. And then leading to what? Leading to formation of a long chain of nucleotide, or a long chain of nucleotides along the leading what? Along the leading strand. And we are saying this DNA polymerase moves in a direction similar to what? Similar to that of what? Similar to that of DNA what? Similar to that of DNA helicase. And that is in a what? In a 5' to 3' direction. What do we mean? What do we mean? For polymerase to do its work, whatever molecule that is being added, for polymerase to do its work, whatever molecule that we are adding here must be added in a 5' to 3' direction. For example, you see here, DNA polymerase moving from here, moving this side like this, But when it is moving this side like this, what has been added here is a nucleotide. What's at the extreme end? It is a 5'. So it means that when you keep on adding these ones together, of course, when these two nucleotides come together, phosphoric acid base is a phosphodiester bond is formed there. When these also come together, a phosphodiester bond is formed there, like that. So you will see, as the phosphoric acid is adding, what is the new chain which is being formed in a 5' to 3' direction. It means by the time this helicase comes and reaches here, still here you will have 3' at the extreme end, as you see these nucleotides, the way they have added these things here. So it means so we are saying RNA molecule called primer attach itself at the 3' extreme end, at the 3' end of the what? Of the leading strand. And it acts as what? An initiator for the process of what? Of replication. After that, we are saying then the DNA polymerase now starts from that polymerase, starts from the primer and keeps moving along the what? And keeps moving along the leading strand. How? Doing what? As it moves along the leading strand, it keeps adding there, it keeps attaching onto the leading strand nucleotides that have got complementary bases. And when those nucleotides are added there, then you form a long chain of nucleotides along the leading strand. And we are saying this DNA polymerase moves in the same direction as the DNA helicase. And we are saying this DNA polymerase adds the molecules, adds a new chain of DNA in what? In a 5', 3' direction. In other words, for DNA helicase to do its work, whatever the chain that it is catalyzing must be moving or must be added in a 5' to 3' direction. Please take note of that one carefully. Why? Because we are going to see that's the reason as to why this other strand becomes the lagging strand. That's why this other strand becomes the lagging strand. We are saying that the leading strand, for DNA polymerase to do its work very well, to catalyze the combination, whatever it is adding must be adding in a 5' to 3' direction. When you check as DNA polymerase is adding here, remember this was 3'. So it means as you see here, this nucleotide which should be at the extreme end should be having 5', if this is 3'. And with the 5' at this extreme end and moving inside having the 3' on the other extreme end, that means we shall be moving in a 5' to 3' direction. That's the direction within which DNA polymerase works. So here we say that since the DNA polymerase on the leading strand moves in the same direction as DNA helicase. What does that one mean? It means that the more this one opens, the more the DNA polymerase will just will be just behind there. The more this one unzips, it was supposed to close these things like that. So it means the more this DNA helicase unzips these nucleotides, is the more the DNA polymerase will just be following here, add nucleotides. In a what? In a 5' to 3' direction. in a 5 prime, because what is being added is being added, the new chain which is being added is in 5 prime to 3 prime direction, in that direction there. So since DNA polymerase on the leading strand moves in the same direction as the DNA polymerase, as the DNA helicase, what does that mean? It means this implies that the leading strand is replicated continuously. It means that's what we also call one continuous what? And continuous, it undergoes what you call continuous what? Replication. So under semi-conservative replication, we have two types: continuous and non-continuous or discontinuous. So it means the leading strand undergoes continuous replication. Why? It undergoes continuous replication because the DNA polymerase, since what is being added, since the new chain which is being added onto the leading strand moves in a 5 prime 3 prime direction, means the DNA polymerase moves in the same direction, as the DNA helicase. So as the DNA helicase unzips, the DNA polymerase keeps adding nucleotides. So it means by the time the DNA helicase finishes to what? To unzip, the DNA of this leading strand will also be done with what? Will be done with adding nucleotides, and new nucleotides will be joining together to form a new chain. And every day you end up having a longer chain. We'll be having a longer chain of you'll be having a new DNA molecule which is having this one as the original and this one as this new chain as the brand new chain. And that's why you call it the semi-conservative. That one I've just shared with you is what is happening on the leading strand. We have not talked about the lagging strand. Whatever I've described here is what is happening on the leading strand. So what do we mean? So it means when you are starting to describe, you are describing the process of DNA replication. You're starting from right away from the start. How? DNA helicase is what begins. You begin by defining what is the DNA, what is conservative replication. Then after we are saying DNA comes and zips. What we have finished in the previous video. The DNA helicase comes and zips. After unzipping, we have seen that these two are oriented differently, and one being the leading, and one being the lagging strand. I've given you the difference as to between the leading and the lagging. Then after that, we have seen because the two strands of the DNA are oriented differently, they are going to be oriented. They are going to be replicated in a different way. How? We have in this now episode we have begun with the leading strand, and we have said on the leading strand what happens. On the leading strand, what we have seen is that the RNA primer, the mRNA primer attaches itself on the 3 prime end of the leading strand, and then it becomes initiates the process of replication. After that, DNA polymerase second enzyme. Of course, the first enzyme was primase, which helps us to form the primer. Then next enzyme, of course, the first enzyme, the first of all, was helicase. Then after we have come to primase. Then from primase, we are now coming to polymerase. In the period after the primase has attached itself on the 3 prime end of the leading strand, we are saying that it acts as an initiator. Then DNA polymerase keeps moving along the leading strand in a 5 prime 3 prime direction, adding nucleotides which are for DNA that are complementary with the nucleotides on the DNA leading strand. So that's why we are saying that the DNA polymerase moves along the leading strand, adding nucleotides, DNA nucleotides onto the leading strand, but following the complementary base pairing rule. And we are saying that when we're showing that way, and when those nucleotides are added, they form a phosphodiester bond and they also form a longer chain. And we are saying this is the formation of a longer chain of a nucleotide along the leading strand. And we are saying DNA polymerase moves in the direction following the DNA helicase. And we are saying DNA polymerase is moving And as the DNA polymerase is moving, what this molecule is being added in a 5' to 3' direction, and that's the direction within which DNA polymerase can do its work very well. And there we are saying, because DNA polymerase is moving in the same direction as the leading strand, as the DNA helicase, then we are saying we are going to see that as the helicase opens, this one, the polymerase will just be adding and a new chain will be being formed. So by the time this helicase reaches at the extreme end, the whole of this thing would have got a new chain being added here, a new chain being added onto the leading strand. So that's how we say this one undergoes continuous replication. That is for what? That is for the leading strand. What about the lagging strand? Follow with me in the next video. Thank you.